In this video, we are going to solve this trigonometric exponential equation. 81 raised to sine squared x plus 81 raised to cosine squared x equals 30. Find the value of x. Notice that in this problem, we are solving for x, which is the angle of the trigonometric function. You can pause the video and see if you can solve this Olympiad problem. Now, let's solve this problem together. Let's begin by noting that 81 is equal to 3 to the fourth. So let's replace all instances of 81 by 3 to the fourth. Now, we can simplify this part here by applying this property of exponents. You have an exponential number inside a parenthesis raised to an outside exponent that is equivalent to the base raised to the product of the exponents. And so we arrive at this. This 4 times this is multiplied. Also, this exponent times that exponent equals this. Then let's recall some trigonometric identities. According to the Pythagorean identity, cosine squared x plus sine squared x is equal to 1, or solving for cosine squared x, that is equal to 1 minus sine squared x. That means we can replace this cosine squared x by 1 minus sine squared x, and this is the result. Then let's distribute this 4 to this binomial to arrive at this. Now, this is an exponential form where the exponent is expressed as difference. We can simplify that using this law of exponent. The base a raised to the difference m minus n, that is equal to the quotient a raised to m over a raised to n. So, this is now the result. This base raised to the fourth divided by the same base raised to 4 sine squared x. Now, notice that this part and this part are the same. So let's use variable substitution to make our algebraic manipulation easier. So we now let u be equal to 3 raised to 4 sine squared x. And so this equation now can be written as u plus 3 to the fourth over u equals 30. Then to eliminate this denominator u, let's multiply the equation by u. And distributing u to both sides of the equation, we have u squared plus 3 to the fourth, which is 81. The u is cancelled, equals 30u. This is a quadratic equation, so let's write this in standard quadratic equation by subtracting 30u from both sides of the equation. Then let's solve this quadratic equation for u. The product is 81 and the sum is negative 30. So we want to find the factors of 81 such that when multiplied, the result is 81, but when added, resulted to negative 30. And those two factors are negative 27 and negative 3. So let's write now this minus 30u as minus 27u and minus 3u to arrive at this. Notice now that this part here is just this negative 30u. Then take this as one group and this one as another group and factor out the common factor. In here, the common factor is u. So u squared divided by u is u. Negative 27u divided by u is negative 27. Now, for this part, the common factor is negative 3. So, negative 3u divided by negative 3 is positive u. Positive 81 divided by negative 3 is negative 27. Then again, there's a common factor u minus 27. So, factor that out. The first term divided by u minus 27, the result is u. The second term divided by u minus 27, the result is minus 3. So, we have a product that is equal to 0. Each of the factors could be equated to 0. And so from here, we have u equals 27. And from the right side, u is equal to 3. But what is the value of u? We know that u is equal to this expression. So let's bring it back. This means that in here, 3 raised to 4 sine squared x is equal to 27. And at the right side, 3 raised to 4 sine squared x is equal to 3. Now, this 27 can be written as 3 cubed. Notice now that in this equation, this base 3 and this base 3 are equal. That means their exponents are also equal. So we now have this equation. 4 sine squared x equals 3. Then divide both sides of the equation by 4. And finally, get the square root of both sides. So we now have plus or minus square root of 3 over 2 for sine of x here. Then at the right side, notice that the exponent of 3 here is 1. So again, we have this exponential equation where the bases are the same, then the exponents are also equal. So 4 sine squared x is equal to 1. Divide both sides by 4 and take the square root of both sides to arrive at sine x equals plus or minus 1/2. Now we are solving for x. So this means that we have two values here. One is for the positive square root of 3 over 2 and the other is for negative square root of 3 over 2. The same thing here at the right side. Now let's remember that this x is the angle of the sine function that will give us a value of square root of 3 over 2. To visualize it, let's bring our unit circle. So x is the angle, and in this ordered pair, the ordering is the first number is cosine, the second number is the sine. So we are looking at the second numbers in these ordered pairs. And we want that number to be first positive 3/2. We have here positive 3/2. And the angle is 60 degrees. That means if we construct a right triangle here with a hypotenuse of 1 unit, this is 1 unit, the central angle is 60 degrees, and the length of this line segment is square root of 3 over 2. So one value of x therefore would be 60, but notice that when I rotate around the circle, every time I make one complete rotation, I'll be going back to the same point. And one complete rotation here is equivalent to 360 degrees. So we now say that the first value for x is 60 degrees plus multiples of 360 degrees representing that rotation. And we express that as 360 degrees times k, where k is a constant from 0, 1, 2, 3, and so on. K are whole numbers. So when k is 0, we have 60. When k is 1, we have 420. And it's a cycle of 360 degrees. Now in radian, 60 degrees is pi over 3, and 360 degrees is 2 pi. So that can also be written as pi over 3 plus 2 pi k. Now notice that there's also y equals square root of 3 over 2 here, and the angle is 120 degrees. So our second value for x is 120 degrees plus 360 degrees times a constant k. The same explanation as in the first value for x. And in radian measurement, that is 2 pi over 3 plus 2 pi k. Now for the negative value of square root of 3 over 2, we have here negative square root of 3 over 2, and the angle is 240 degrees. And another one here, and the angle is 300 degrees. And the corresponding radian measurements here are, for 240 degrees, it's 4 pi over 3 plus 2 pi k to account for the cyclical nature of our solution here. For 300 degrees, that's equivalent to 5 pi over 3. Then we add 2 pi k to account for the rotation. Then when sine of x is positive 1/2, notice also that we have here 1/2 and the angle is 30 degrees. So we have another solution here. In radian measurement, that is pi over 6 plus 2 pi k. Then there's another 1/2 here, and the angle is 150 degrees. The same explanation as the previous ones. Then when sine of x equals negative 1/2, we have negative 1/2 here, and that is at 330 degrees, and another one here at 210 degrees. So we have two more solutions and their corresponding radian measurements. So these are the 8 values of x that will make this equation true. And to check if our answers are correct, I use the Desmos graphing calculator, and it's verified that for x equals pi over 3, 2 pi over 3, 4 pi over 3 until 11 pi over 6, we arrive at a correct equation. Notice that the right side are all equal to this 30. And so, this problem is now solved. So thank you very much, and we hope to see you again in our next video. Bye for now.